Hello students. Today we're going to add on to our conversation about Ohm's law and electricity, and we're going to talk about series circuits. This is like page 3 or something of the lesson guide if you printed it out, so you can use that to follow along if you'd like to. I have a picture of, it's called a schematic drawing of a circuit wired in series. In series, it means that these items, maybe light bulbs, maybe fan motors, maybe heaters, maybe your refrigerator, maybe your stove, whatever. These things are all providing some kind of resistance to the current flow in the circuit. So the current flow would go, and it would have to go and bypass or go through all of those items, which means that in series, one of the downfalls of series is that if one of them does not work, let's say you don't have, or not that it doesn't work, but you don't have it turned on. You don't have your TV turned on, therefore nothing else in your bedroom will work because it's wired in series. Not even the very first one. You would think that your current flow would come and hit this, whatever this item is here, and that would work, but no, it does not. None of the circuit will work if one thing is turned off. So like I used your example of your bedroom. If your bedroom was wired in series, then you'd have to have your light on, your computer on, your TV on, so that you could run the air conditioner. All right, does everybody understand that? Okay. The other thing that goes on with a series circuit is that you have voltage here, and then as you pass through these things that are wired into the series, they're not getting equal voltage across the series, across the circuit. So they're not getting the same amount of strength from the battery. There are a few rules for series circuits. One thing, looking at the diagram maybe from above, current is the I value. So current will stay the same. Do you see that it's 0.05 in all of those? It is the same everywhere. The total resistance, that's what this 800 ohms is. It is the sum of all of the individual resistances. Each thing that you plug into a circuit will have a different resistance to it. Like a light bulb would have a different resistance than an air conditioner. An air conditioner is going to suck a lot more energy away. But the total resistance is the sum of all the individuals. Okay. Same thing with the total voltage. The total voltage is the sum of the voltages in each one of the resistors. So it's the sum of all of them. And the total power, we'll have to fill ourselves in about power, but it is also the sum of all of them. Series circuits are really easy to calculate because these 4 little rules right here are very easy. But as far as wiring, they're not really efficient. Because again, like the bedroom example, I said you have to have all those things on so that you could run your air conditioner. If you turned your air conditioner off, then nothing else would work either. So down below, we're going to do a few examples of just some really easy questions, just so that we get the hang of those 4 little rules right there for series circuit. So the question says, what is the total resistance? So out here at the power source, the total resistance from up above says this the sum of all of the other ones. So we add all of these together to get the resistance that's out there at the power source. So I get 80 ohms. And ohms is like a little horseshoe thing. Looks like a little upside down horseshoe. It is the Greek letter ohm. It is named after the scientist that discovered it. His last name was Ohm. So then here, if we know the total resistance is 800, and according to our rule, it's the sum of all the individual ones. So we know these. Is there a way that we can find that missing piece? Yeah, there's different ways you can add those other ones together and then subtract from 800. Or you could do 800 minus 100 minus 250 minus 150. That means that this missing resistance is 300 ohms. Now our next example is looking at the intensity, or what's called the current. Current in a series circuit will stay the same in every branch. So if it's 0.02 in all of those other places, down here would be 0.02 also, and it is measured in amps. Our next example is talking about voltage, and if we look back at our rules for the series circuit, voltage will be the total again, so that if we have this as our total, and we know these 3 branches, we can find the missing branch by doing a subtraction. So 120 minus 24 minus 20 minus 20. So a lot of you guys will think about, oh, I'm going to take this 120 and then it will evenly divide between my 4 little resistors. And it doesn't evenly divide because not all of those things are the same thing. If they were all 4 light bulbs of the exact kind of light bulb and the exact resistance from the light bulb, yes, we could take 120 and divide it by 4. But because these are obviously different things wired into this circuit, we need to apply the rule for voltage. All right, we're gonna just jump right in and do a big giant one. Now, how you do find all the missing pieces here are there's no cut and dry step 1, step 2, step 3. You've got to kind of look at what you have and go for there. I'll tell you that for our purposes today, we're not going to worry about the power in these. We'll save that for a different day. What we have to remember is Ohm's law. Ohm's law from last week, we had V, I, and R, but we also know that V can also be represented by the letter E because it means electromotive force. So we're going to use that, and then we're also going to use our 3 rules. Our 3 rules were that I stays the same, voltage is the sum, and resistance is also the sum. So looking at this, and that's what you're going to have to do. You're just going to have to look at it and go, what can I do? What do I know? What can I do? I see that we know all of these resistance values, and we know that resistance will total or will sum all of those together. So if I add 100, 250, 150, and 300, that will give me the resistance out here at the power source, which is 800 ohms. All right, so now I ask myself, can I apply a rule for series circuit, or could I apply Ohm's law? Out here, I see that I know E and R, so I can apply Ohm's law to that and find I. Remember how I do this? If I'm going to find I cover up I. And that'll tell me that I'm going to take E divided by R. So here, E divided by R means that I take 40 divided by 800. And I get my I value is 0.05 amps. And what do we know about I? Well, we know that I is the current and that it stays the same throughout the whole circuit. So that means that in every one of these branches, it is also 0.05. Wonderful. So now we step back again and say, well, what do we know? What do we know and what can we find? I see that in every one of those branches, I know I and R. If I know I and R, that means that I can find the E value. Do not do what you guys always want to do and say 40 divided by 1, 2, 3, 4 branches. They are not all the same piece, so you can't do that. What we have to do is look at each individual section and apply Ohm's law to it. Ohm's law, if we're going to find the E, remember we cover up the E, and that would mean that we take I times R. So right here, I'm going to take 0.05 times 100, and I get 5 volts. On this one, I times R, 0.05 times 250, I get 12.5. Oh, I should put volts over here. Oh, I did. At this branch, 0.05 times 150 gives me 7.5 volts. 0.05 times 300 is 15 volts. And I believe we have now found all of the pieces in that series circuit. A reason why you would do this is that then you could wire it and actually hook a meter up to these, like I could hook a meter up here and here, and I know that the readings across that resistor should be 5 volts, 0.05, and 100. And if it's not, that means I've got a short somewhere. That means I've got it wired wrong. That means something's going on with my circuit. Okay? All right, so like I said, series circuits are really easy to calculate because the rules, these 3 rules, are very straightforward and simple. And Ohm's law is also straightforward and simple. But series circuits not really used in our homes anymore because of its limitations. That if one goes out, then that means they all go out. If you think about old-time Christmas lights, Christmas lights are wired in series circuit. If one bulb fails, then the whole string, or at least maybe half of the string, will go out, and you'd have to troubleshoot as to which one it is. That's the most prevalent example of what's a series circuit. I want you guys to go ahead and go to the Google quiz now. Answer the questions on the Google quiz. Make sure you hit submit. If you have any questions, you can email me at cjones@ictc.edu. I will also be available on Zoom at 2:30 to 3 o'clock every weekday. The Zoom link is in the stream of your Google Classroom, and you can always pop in and ask me a question. I will be there to answer anything you guys need. All right? I hope you guys have a great day, and I look forward to seeing you again soon. Bye.